Hi, in this video I'll be going over homework 2, where we'll learn about regression lines, residuals, probabilities with Venn diagrams, and probabilities with two-way tables. I will give step-by-step explanations for each problem and cover definitions. So let's go ahead and get started. In problem 1, it gives us a word problem with 4 questions that go along with it. It tells us, a used car dealership collected data on the selling prices of cars and their ages and years. Based on a sample of cars of the same model, the least squares regression line for predicting price in dollars from age and years is price minus 18,500 minus 1,250 times age. The first question asks, what does the slope of this line say about the relationship between price and the age of the car? We first need to find the slope, which in this case is negative 1,250. Since the equation they gave us is already in slope-intercept form, we know that whatever number is in front of the variable is the slope. Since our slope is negative, we can decipher that for every year older the car is, the value goes down by 1,250. This makes sense because cars lose value over time. Moving on to problem 2, it asks, what is the predicted price when the age of the car is 0 years? How would you interpret this value? So, we first need to find when the car's age is 0. We can do that by plugging in 0 to the equation. When we multiply negative 1,250 by 0, we get 0. Then we are left with 18,500 minus 0, which is obviously still 18,500. That would be our answer for when the car's age is 0. As for how we would interpret this value, all this means is, in the context of the regression line at least, 18,500 would be the starting value when the car is brand new. Let's move on to question 3, which asks us, predict the price of a car that is 5 years old. To do this, we would need to plug in 5 to the equation. Then we would multiply negative 1,250 by 5 and get negative 6,250. We are then left with 18,500 minus 6,250, which would be our answer of 12,250. So according to the equation, a 5-year-old car would be 12,250. Now for our last question on problem 1, it asks, would it make sense to use this model to predict the price of a car that is 25 years old? Why or why not? Let's test this out by plugging in 25 to our equation. We'll just do this the same way we did it the last few times, and solving this would give us negative 12,750. This would not make sense considering a car price cannot be negative. This tells us regression lines can become unreliable when used outside of the data range collected. Now that we are done with problem 1, we can move on to problem 2, which tells us fuel consumption Y of a car was recorded at various speeds X. Fuel consumption is measured in miles per gallon and speed is measured in miles per hour. Software output gives the least squares regression line as Y minus 70.243 minus 0.329x. The observed data and residuals are shown in the table below. The first question asks us to make a scatter plot and regression line based on the data. First step to making the scatter plot is to draw the X and Y lines with numbers that correspond to the numbers in the chart. I went up by 10s for my X line and went up by 5s for my Y line. And make sure to label your lines speed and fuel. I then plotted the X and Y points from the table, but don't worry about the residual numbers yet. Then we need to make our regression line. To do this, we need to use the regression line equation and find 2 values from the table to plug in. I find it easiest to use the smallest and largest numbers to make the line. So in this case, it would be 20 and 80. We will then plug in 20 and 80 and solve as normal. So when we plug in 20, it gives us 63.7, and then when we plug in 80, it gives us 43.9. This gives us 2 points that we can use to make our regression line. So then we plot both of those points and then put a line through both of them to make our line. Now that we've made our scatter plot, we can go to question 2, which asks, would you use the regression line to predict y from x and explain your answer? My answer would be yes, but with caution. Since the data points are not too far from the regression line, as we can see, using it to predict y from x would give a pretty good estimate. However, going too far outside the range of data, like 5 or 120 miles per hour, the estimates wouldn't be as accurate. Now we can go to question 3, which asks, verify the value of the first residual for x minus 20. Verify that the residuals have sum 0. To do this, we would first plug in 20 to our equation. We actually already did this for a point in our regression line, so we can look back to see that our value was 63.7, or more accurately at 63.663. Now we can look at our table and see that the actual y value was 49. We can subtract the actual value, 49, by our predicted value of 63.663 and get negative 14.67. If we look at the table, we can see that that matches the residual value given. It then asks us to verify that the residuals sum to 0. So if we add them all together, it comes to 0. Now we can go to question 4, which asks us to make a plot of the residuals against the values of x. Draw a horizontal line at height 0 on your point. How does the pattern of the residuals about this line compare with the pattern of the data points from the regression line in your scatter plot from part A? So to do this, we start off by making the x and y lines, with x being speed and y being the residual this time. We plot the points using the x values and the residual values from the table. Then we can make a horizontal line at 0. Looking at the difference between the residual plot and the scatter plot in the first question, we can see that the new one has the points bounce randomly around the horizontal line. This tells us the regression line was a good fit, as if it was curved, we may have missed an underlying pattern. Since we finished all the problems from problem 2, we can move on to problem 3, which tells us a company retains a psychologist to assess whether job applicants are suited for assembly line work. The psychologist classifies applicants as one of A, well-suited, B, marginal, or C, not suited. The company is concerned about the event D, that an employee leaves the company within a year of being hired. Data on all these people hired in the past 5 years give these probabilities. Question 1 asks us to sketch a Venn diagram of the events A, B, C, and D, and mark on your diagram the probabilities of all combinations of psychological assessment and leaving or not within a year. To make this diagram, we would first need 3 circles to represent A, B, and C. Unlike a typical Venn diagram, we don't overlap these circles because they are disjoint, meaning they are independent from one another. Next, we have to account for the probability of them leaving in a year, so we would add circle D that overlaps all A, B, and C. Then we look at the probabilities they gave us to fill in the numbers in our diagram. Just looking at A for now, we can see they gave us these 2 probabilities. Since 0.4 accounts for the probability of being in group A altogether, and 0.1 accounts for the probability of the worker to leave in a year, we would need to subtract the 2 to know the probability of the worker not leaving. That would give us 0.3, so we can put this in A, and then keep 0.1 as the overlap between A and D. If we apply the same logic to the rest of the circles, we can fill in the rest of the diagram. Now that we've completed the Venn diagram, we can go to question 2, which asks, what is the probability that an employee leaves within a year? All we would have to do for this is add all the numbers together that overlap into D. So 0.1 plus 0.1 plus 0.2, which would give us 0.4. We would convert this into a percentage, so the answer would be 40%. Now that we have completed all the questions from problem 3, we can move on to our last problem, problem 4. This one tells us a striking trend in higher education is that more women than men reach each level of attainment. The National Center for Education Statistics, which classifies all subjects as male or female, provides projections for the number of degrees earned, classified by level and the sex of the degree recipient. Here are the projected number of earned degrees in thousands in the United States for the 2027-28 academic year. Our first question asks, if you choose a degree recipient at random, what is the probability that the person you choose is a man? To do this one, we first need to look at the total amount of male degrees, which is 1,057. Then we would divide this by the total amount of degrees, both male and female, which is 3,990. After dividing this in my calculator, I got about 0.415, or 41.5%. So our answer would be 41.5%. And this is the probability that you would randomly pick a male. Now, question 2 asks, what is the conditional probability that you choose a man given that the person chosen received a master's? This one is a conditional probability, which means we're looking at a smaller group of the data. So we'll only be looking at the total amount of master's degrees, 113, and how many males got a master's degree, which is 340. So we would need to divide 340 by 813 and get about 0.418, or 41.8%. This would be our answer for question 2. Now, 3 asks us, are the events choose a man and choose a master's degree recipient independent? How do you know? 2 events are independent if knowing one doesn't change the probability of the other. So if the probability of being a man overall is the same probability of being a man given that you are in the master's category, then they're independent. So if we compare the 2 probabilities we found, which is 41.5 and 41.8, they are pretty close to identical. This would make them approximately independent. Now that we are done with all of the problems, I hope you've learned a lot about regression equation, residuals, Venn diagrams, and two-way tables from this video, how they can connect to real-world data. Thank you for watching.